be very, very efficient power-wise because it's put at that low level, and it just hides that away from you and manages it all for you. And then the sensor framework sits on top of the drivers there. So it means that if you have to write code to talk to a new sensor, you're writing it in a reasonably abstract way, and it's going to work for all platforms. You don't have to just write it for a specific one, which is nice. How many people are actually in this field who work in IoT? Can I just have a show of hands? There's a few. Has anyone written code along sensors like this? Have you ever had to port it to another platform?
Yeah.
Yeah. It's painful, isn't it?
Yeah.
Yeah.
Sure. Yeah, that looks great.
Yeah, this takes a lot of the pain out of it. So it's one of its great features. So what boards does it support? It actually supports, there's about 100 odd boards that it supports. It supports Cortex. The Cortex boards are the ones it's mostly aimed at. So M0, M4, 2 M4, so that's M2, 3, and 4, I think. M7 microcontrollers. They are a very, very popular chip. STM, for example, make a lot of boards that have Cortex in there, and so do Nordic, who mostly like Bluetooth chips as well. It also supports MIPS and also recently RISC-V chips as well. It'll also run on hobbyist platforms like high-level Arduinos, Raspberry Pis, microbits, Adafruit Feather boards. So it runs on a lot of things. And if you were in my talk before, it also runs on the Ruby, the nice little Bluetooth coin device. So it supports Bluetooth, and it actually supports, the Bluetooth support is very up to date and quite modern. So it supports Bluetooth Low Energy 4.2 and 5. And you get to choose which features that you want. Because these, I don't know if you know, but these days a full Bluetooth stack can do a lot of things. It's got and you may not need all of them. Like if you're just advertising a little bit of information to a phone to connect to it or something like that, you probably don't need the Bluetooth mesh support, for example. So it's tunable so that you can only use the bits that you want. It supports up to 32 connections, 2 megabits per second throughput. They've been tested on this on quite some low, simple hardware. And it's also portable, so you can swap the Bluetooth chips as you need. So for example, in one version of hardware, you might be using a Nordic chip, and another version of hardware, you might be using another one. And basically, your code is going to be identical. So again, you don't have that problem or pain of trying to port from one chip to the other. So this is what the code looks like. This is just a very, very simple Bluetooth code. So basically here we're creating a random address and setting that up. And then we're advertising that. This is acting as like a Bluetooth beacon. And yeah, there's not much to it, basically. I mean, this isn't particularly interesting code in that all it's doing is advertising a string of 11 hexes to any devices that is around. So like, again, it's not particularly, you probably want to do a little bit more than that. but you can get the concept in that it's actually not that complex, and it's fairly easy to do. It also supports Wi-Fi. It only supports low-speed Wi-Fi. It has native support for TCP/IP and UDP, and it also supports CoAP and 6LoWAN, LAN, PAN, whatever you want to pronounce it. It's a protocol that is, I've never actually used it, but it's sometimes used in IoT. There's a few other protocols that it supports, but I'll get to those a little later. So there's 2 file systems that it supports. One of them is called the Newton Flash File System. NFSS, and it's designed to have minimal RAM usage. And there's still a little work that needs to be done on encryption and compression in there, but it works quite well. The other one that it supports is the legacy FAT file system, but that has a much more overhead in terms of memory goes. So depending on your system and how constrained it is, this is the one you probably want to go with. So there's a sensor framework, and that sits on top of the drivers and HELs. So this basically means, as I was saying before, that you only have to write the code to deal with the sensors once, and then it's going to work on all the platforms. These days, and it's pretty easy to do this, because these days a lot of sensors use standard interfaces like I2C or SPI. And so if you've written one, you can have a look at one that someone else has written, and just copy that and work out what you need to change. So here's some example code for the sensors. This is an accelerometer that we're setting up. So basically you have a sensor in it that you have to pass a couple of parameters to. This is I guess a BNO 055 accelerometer. And then we can say what the sensor is down here. Scroll it. Oh, that's interesting. I can scroll on my screen, but it doesn't scroll on that screen.
You have to go over with the mouse to the other screen.
Yeah, there we go. So then you can set up, what sensor information you're looking for. In this case, we're looking for accelerometer, gyroscope. It also happens to give us temperature and parity as well, which is most accelerometers do that. Then we set up the interface, and then we register the sensor, and that's it. All right. So again, not a lot of code to do something, but that's quite straightforward. And this could be put in a task, and again, you could measure this every couple of minutes or whatever. So I was talking before about packages and projects. So projects are a collection of packages, and they are released and versioned in repositories. It actually uses Git as part of the package management system. And you basically have a little script which defines what package you use. It's sort of, I won't say it's like Maven, because Chris will tell me it's not. But you can think of it in that way. You just specify, here are all the packages that I want to use, these are the versions of them that I want to use, and it will go off and get all those for you. And this way, you can actually maintain and reuse packages across multiple projects. You can pick and choose which ones you need. You can also have different packaging set up for debug and release. So you might want to include extra logging inside debug. You might want to include other features inside your debugging platform that you don't actually release. And you know exactly what versions you're using. As I said, this is actually a fairly serious issue in some other platforms. There's a whole lot of internal packages that come with Minute that you can use and specify which ones you want, but you can also specify external packages as well. So you can just point to any random Git or GitHub repo and it'll be able to put those in. It also makes it easy to find third-party packages. The only problem with this is that it's probably a little different from what you're used to if you're involved in this space, in that it doesn't use make to compile things. So I'll show you a little example of that. So here is an example project config. We have the project name defined up at the top. We're saying here that we're using the core repository. That's the only thing we're using. And then we're saying we want the latest version of that from the Apache GitHub repo. So, and you can just specify this in a similar way for each of the packages that your project uses. So in this case, we've got a Blinky program. And we've got a little bit of information about it. You can think of this as meta information. This is easily searchable so that you can find your packages and so forth. And then we've got the dependencies that it depends on. So in this case, it depends on 3 core properties. It's the operating system itself, the hardware extraction layer, and we've also put a console in there as well. Console's just for debugging this Blinky program. Generally, a program to blink a LED doesn't need a console, but that's what we've got here. So one of the reasons for splitting this out into external and internal or internal and external repos is that some of the
and external repos.
I think that's working, Chris.
Yeah, that's working.
So, is that not all the packages are compatible with licensing? There was some libraries that they wanted to use, and even though they talked to the vendors were not interested in changing the licensing. They still had GPL or other licenses along those lines. So the only way they can do that is to host it externally. And for example, there's a Nordic Adreno 0 and there's a STM1 board there. There's different packages there. The MCU boot program too is also external. So on the MCU boot, there's a bootloader, and the bootloader can either be in ROM in the memory itself, or it can also be on flash, which is sort of quite interesting. And what it does is there's a couple of setups that you can have. Most of them rely on it depends how much memory you have and what you're trying to do. So you can, for example, have an A image and a B image, and the bootloader will say, let's run the A image. So if for some reason that A image isn't working, or it fails the checksum when it starts up, it'll automatically switch over to the B image. So it can swap between the images as needed, and this is also used in the over-the-air update mechanism. So basically, one of the common issues is that, like, if you've got an image and you load a new one up over the air and it gets corrupt, you reboot the device, you've now bricked it. There's no way of recovering from that at all, other than physically going to the device and doing something with it. With a system like this, what will happen is that one of the images will get uploaded. It will be put in, say, slot B. The bootloader will then be changed to boot slot B. It runs, it doesn't work, it resets, goes back to running the old software on slot A. So that's a really nice feature. Each of the images are either hashed with SHA-256 or even RSA signatures if you want. So that can be securely done. And you can be pretty confident that, you know, what software you said you were uploading ends up being the software on there. So I've gone a little bit over that. So you can generate boot images from tools that Minute supplies. Basically, it makes an image flash map, and you can work this out. The images are signed, as I was saying before. You can, if you want, not use that swapping mechanism that I just described. You can just take the risk and overwrite the image, but you know that is slightly risky. But you may have to do that if your memory is really constrained. So you can also upgrade the software over Bluetooth and Wi-Fi, depending on how you want to do it. You can set what this is, so it's not like all devices that have this can be updated by Bluetooth, because that may in some cases be a security concern, or Wi-Fi. You don't want some random person coming up to your device and trying to upload something new to it. So, and you can also upload via direct connection as well. So it has some very interesting power management features. It's got very deep sleep and wake up. Quite often, even with deep sleep stuff on real-time operating systems, you still need some sort of timer or counter. Because, for example, if you've got a task that wakes up every 10 minutes and you put it to sleep, or deep sleep, it's got to know when 10 minutes is going to come up and still wake up. So it actually works out when things need to happen and wakes up at the right time. So it actually has a tickless idle task. So that basically means it consumes almost no power whatsoever while it's sleeping, which is a really nice feature. It also has sleep, power management around networking, so it can actually put the networking interface to sleep. If you've got, say, an Ethernet interface on it or something along those lines, that can consume a large amount of power. So turning that off and on as required is quite a useful feature. So debugging. This is where it helps you a lot. So it's got a lot of logging statistics about what goes on inside the system, and these can be compiled out at production time. So you you're not getting that cost on the production system, but you can still debug it quite easily. The logs can be written to RAM or flash. So if the device crashes, you can look at it and see what's going on. There's a circular buffer that it uses to write all these logs to. So it's not going to run out of memory. It just keeps cycling around and around and around and around like this. It can also write out core dumps to flash, or that spare image shot where you're actually debugging stuff. So you can get a full dump of what's gone wrong and go through that and try and work out what's happened. It also has stack guards and memory tracking. So it actually will tell you when your stack is overwritten, but won't crash the program, which is a great feature. It's like that saved me so much hassle. And it also has a unit testing framework. The unit testing framework you can actually run on the device itself. So you can actually run all your unit tests on the hardware, which is another great feature. As well as doing that, if you were in my previous talk, one of the things I mentioned is that often testing stuff on hardware takes time. And if you have to test on the target device all the time, you've got to keep loading up the new software, testing it, looking through the logs. It can get a little bit tedious and a little time consuming. So Minute also has a simulator. So it runs on Mac and Linux, and basically you can develop all the code off the hardware platform altogether. And you can run unit tests there. And running unit tests on your local machine is much faster. So you still have to test on the final hardware. Like, don't just use this, because that's going to get you into trouble. But it's another great feature, and it just makes developing on these platforms so much easier. So one thing I haven't said is how big is it? The core fits in 1K of RAM and 6K of flash. So it's tiny. So the core is basically just the multitasking bit and a few other bits around that, power management, a few things like that. Bluetooth, on the other hand, is a little bigger. It can take between 5 and 15K of RAM and up to 100 kilobytes of code, but it depends on the features that you select. And this is pretty typical for a Bluetooth stack. It's not, it's not that out of the ordinary for it. But the core system there is very lightweight and well tuned. And that's going to increase some more features that you add, like if you add the one of the file systems to it, that goes up and so forth. But you get to choose and pick, which ones you want to add, so that's good. Security has been built in from the ground up. There's a unique device identification API. You can generate certificates. The bootloader is secure. All the checksums, all the images have proper checksums. It supports TLS, and it also supports lots of different versions of Bluetooth security. And this has all been built in from the ground up, so it is a really secure system. So just what's new? So relatively new, this is a few years old now, but it's been improving over the last couple of years, is Bluetooth 5 and Bluetooth Mesh support. It's also got LoRa and LoRaWAN support. Is everyone familiar with LoRaWAN? No, LoRa is long-range, low bandwidth, wide area networks. A LoRa base station will typically cover, say, 10 kilometers and support 20,000 devices. Bandwidth is tiny though, but it's very good for this sort of IoT type device in that you just want to put small amounts of data, sensor data out. There's been a lot of work on the sensor framework, Cortex M7 and other board support. The RISC-V is the most recent one. We now have encrypted flash support. There's a battery sensor, so you can work out other power management features with there. And it's got a true random number generator support as well, which can be, that's basically required for some of the security features. And what's really new is we've got lots more boards and lots more processors. There's a generic bus driver. There's improvements to the crypto framework. The task pools is probably the most significant change in recent time, and that is that you can now, rather than what I showed you before, where you created the tasks up front, you can actually create tasks on the fly. So you can create and remove tasks, and they all run from a task pool. And that can keep your memory consumption down, and it means you can run a lot more tasks and can be a bit more customized in what you do. There's a generic data streaming interface, and they've also recently got Bluetooth 5 certification. So that means you don't have to get it certified yourself, which is a great thing. Has anyone gone through the certification process? What's involved with that? You don't want to, trust me. Yeah. So I'll make these slides so they're publicly available somewhere. There's some links there if you want to take some photos as well, where to get some more information about the Minute project. But that's basically it for me. Do we have any questions? Yes, over there.
Is there any now customer user using the system now?
Yes, yes. Large number of customers are using the system. Even before it came to Apache, it was used commercially. The first project that I know of is probably 5 or 6 years ago in Australia, where it was used for smart meters for an electricity company.
Okay. Any customer from automotive user?
I don't know off the top of my head. I would not be surprised if there isn't.
I'm working for Mercedes and we have similar thing for operating system. Just what I'm asking, where we have similar issue to run it real time. So wondering if it was considered for this purpose or not.
I don't think it was specifically built for the automotive industry.
Not specifically.
But it could certainly be used in it, yeah. It solves a lot of the problems that the over-the-air updates and security being two of the major ones that I can think of.
Maybe with Alvarez after.
Yeah, sure. Mm-hmm. Any other questions? Oh, yep. We've got some. We'll take the one off the back there first.
Any plans to support trusted firmware?
Any plans to support trusted firmware? Do you want to talk?
So especially from the Cortex series, I've got a trusted firmware project, so it's using methods.
Okay. Yeah, I'm not familiar with that, so I don't know if there's any plans to support it. The security that they've built in around the images with the checksums and the signing and so forth makes it reasonably secure. I don't know what the trusted firmware gives on top of that. We'll have a chat afterwards and you can tell me about it. All right, down the front.
I just recently learned about the Yocto framework.
Yeah.
And I mean, I guess there's some obvious differences in size, I guess, but can you say something about how this really differentiates from Yocto, when to use which one?
I think Yocto actually uses some of the minute code.
Oh, really?
Yeah, I think. Being open source.
Yeah.
It's
interesting.
Yeah. It's one of the other. Is it? It's done by the Eclipse Foundation. Is that?
No, it's
No?
Linux.
Okay. Oh, the Linux Foundation. Yeah, I'm pretty sure that is the one. Yeah, it actually uses some of the minute code.
Okay, that's good.
Yeah. I don't know the comparisons between the two or where where they overlap and what they don't. But that would be interesting to know.
One of my major goals for, let's say, the next year for the PLC4X project is to sort of port it to some language that I can use Minute to create applications to talk to industrial controllers. So I've been reading on Twitter, there's a lot of mentioning Go and Rust, and what language would I ideally write those drivers in that I can include them in Minute?
So you want to run it on the hardware, or do you want to run it on?
Yeah, I want to build hardware solution running Minute, and that has drivers that sort of come from the PLC4X project, for example. And which language would I need to?
Well, Minute is written in C, so that's probably your first choice. Don't be dismissive of C.
Yeah.
So, but it would not be impossible. You know, you can write it in something else if it's not on that hardware itself.
Or
you
I
can
want it
use
on the hardware. Oh well.
As far as I know, they're not looking at any other languages.
Okay, so C it will be. Yeah.
Yep, another question then?
Yeah, one very minor question first. You said it's a top of the project
Yes.
because the dev making is still
yeah.
incubator.
Yeah, it will still work.
Okay, and the second more technical question is, as you know, we're doing a lot with PLC and industrial real-time stuff. So you said it's real-time operating system.
Yes.
How can we, or what means you have to control how your tasks executed, or how does this work?
That's entirely up to you. So it doesn't
Okay.
impose anything along those lines. It's mostly more the low level. Here's the task. Let's run the task. Let's manage the power. Let's do all that stuff. How you actually communicate with it and tell it what to do is sort of higher level stuff that it doesn't really deal with. So, but you put some, well, it depends how you want to talk to it. So if you're talking via Bluetooth or Wi-Fi or Ethernet, then you pick that and you program your own interface on top of that. Yeah, but you'd have to do all that work yourself. It's not included in one yet.
Okay.
Do we have any other questions? Oh, over there, yeah.
I want to know that this operating system will have the Java runtime environment.
Sorry?
Java runtime environment. Java runtime environment.
The Java runtime? No, it's not. It does run on the Java runtime. It's written in C, and it's written to run on quite constrained devices. So the devices we're talking about only have 32, 256K memory. That's not going to be enough to run a Java runtime.
So is that possible to run on Java without environment?
I don't think it's possible to do that. Just because what it's written C, not Java.
So can you run the program by low level?
Yeah, I have read recently that Go has been put to, there's like a mini Go or micro Go. Tiny Go, yeah. I don't know of any work that's been done around that. I can't recall anything being on the mailing list. But Go and C are reasonably similar, so I think it would be that.
Depending on the binary form that uses for accessibles, it should just kind of
Work, yeah. Thank you for the question. All right, thanks everyone for coming along. If you have any other questions, please find me throughout the conference. I'm going to be here the whole 4 days, and I hope to see you and have a chat to you.
Perhaps a little announcement. In this room, we will have, after the short break, the talk from Chris about PS4X, I guess.
Yeah.
At what time is it at?
11:30.
11:30. So grab some coffee and make sure to not miss that.
Is this the talk about Industry 4 or it's a different one?
Yeah, yeah. Communication with industrial stuff.
Coffee is upstairs, not.
Yeah, upstairs and then go through the whole beauty.
Exactly.
Until you
So,
meet the
Not a good organization.
You know exactly what task is going to run.
And don't get
and
don't
nothing
stop at
that
the
can't be interrupted. It's finished.
Okay.
So that's the way
This
they
is a
design
nice
it.
control.
It makes it more predictable in what it's doing.
Okay. That was both a blessing and a curse.
Do we get money if we do that? Well, we should write it. Well, I'll make some focus and write it.
All right, I'm going to go grab a coffee and then I'll come back.
Yeah, I think we also.
Can
Should
you
I
just
bring
bring
one?
me
Yeah,
a
of course.
coffee with milk
And
and water if it's
of course.
of course.
Of course. So have you got the Chris?
Yeah, I've got stuff.
Yeah.
I've got the ideal slot for that.
Yeah, you can't really look at
Yeah.
I'm just going to take that. You take the book?
No, I'm going to I'm just going to take a photo of Chris's
Yeah, not really.
toys.
set up yet. And Toddy's gonna come.
Oh, we could place a swing on it.
Like that's the switch.
Yeah.
Oh, we have replaced. No.
Have you tried turning it off and on again?
No stickers on it.
Ah, yeah, well, I've got stickers with me.
No, I mean also no Pragmatic Industries, Pragmatic Minds, Third Century. So, it's really nice. They sent it in way.
Yes. Well, it's $2,000 this way, and they gave it to us for $500. So that was nice of them. And it sort of supports a lot of protocols.
Thanks for helping.
So, yeah. So it's
driven by PLC for X?
No. PLC4X doesn't run on any, but we're planning on sort of building an agent,
Okay.
so we could actually run it.
Okay. So this is just PLC, right? That's
Yeah, it's just one other PLC. Don't need to plug that in. Too many. If you've just got cloud stuff, you only need is some internet connection. If you've got IoT stuff, you always need a lot of cables.
so you will demonstrate.
Or I think this one I'll plug in because that blinks.
So Phonics Contact is a company.
Yeah. So I have this blink too.
You will demonstrate how to collect data from there.
Yeah, that's the main intent of the PLC4X, because we want to do all the cool stuff for the industry, but for that we need to talk to their hardware. Did I mention too many cables? Then I have to jump to the restroom. Be right back. No, I'm not going to install Mac updates now.
We also tried PLC4X and we built a PLC developed by how to say Mitsubishi.
Mitsubishi,
Yeah.
Modbus.
Yeah, and we bought some sensors and try to use PLC4X, PLC4J to collect data with Modbus protocol from the
Okay.
PLC, and then store the data into RTP. We have a demo, but I didn't take the hardware care. It's cool. It takes so much.
Yeah, now I can't even play study here anymore. Just shove it in the back.
Logo pad.
Now my web server is running. Okay. So I'm set up. You guys are gonna stay there. I'll be back in a
Okay.
minute.
OK。它就是怎么从 PLC 上把数据采出来，就这些 PLC， 这就是硬件嘛，就是那些工业设备上，它里面有很多控制器 ，PLC 全是叫 programmable 编程的 logical 逻辑控制器，可编程逻辑控制器。这是啥软件？这是网易，
这个是网页不用 PowerPoint 的是吗？因为都是收费的是吗？
对。
谁会用这些东西？不是应用在什么地方？
就什么天元啊，他们怎么采数据就是这样子。
哎，他们的机器本身不能采数据，就是你需要有另外一套东西来帮他采吗？
就 PLC 可以和这些东西打交道，这些都是那个，就是因为它通电嘛，知道电源的变化，对吧？它电源多少，然后这个 PLC 它通过这个跳线跳过来之后，它可以给它发送指令，说你要把电源调到几，或者我给你发个指令说告诉我现在电压是多少，这 PLC 在这儿，然后 PLC 也可以做，因为它要可编程逻辑控制器嘛，它也可以判断说当你的电压到多少时候你再采控制。是用那个机器自动化控制的那个原理。然后那数据就它这真的只有逻辑，对吧？但它其实可以不要把数据拿到，拿到之后怎么把数据吐出来？吐出来的时候是有各种各样协议的 ，Model Bus 协议比较流行 Model Bus 协议，还有其他的协议。然后吐出来之后就吐到一个它自己在laptop， 然后这laptop到 laptop 上之后，这个数据就可以随便调换。你下一个场吗？11点半，在哪？11点半是吧？对，6瓦，B 挨在后边是6，不是7吗 ？B 是5，还是6？加一个。我下一个是在Vista 8是吧 ？Vista 在哪儿？你那儿不清楚。3个。
I think it's called Internet of Things because of all the things you need to plug into your laptop.
We got some people watching on the live stream.
Yeah?
We had it up to like 5 for a little while earlier. Looks like.
I posted in my company's
Yep.
channel. Just look up some entertaining. Yeah. I think the little thing doesn't. Yeah, it doesn't like traveling.
Actually, I have one question. You only can use PLC X to control to get data or write data from PLC, but before that, we have to use the PLC Windows software to setting the PLC.
Yeah, well, the PLC is programmed the usual way. It's just a device that exists there, and what PLC4X does, it's able to get data out of it.
Yeah. But if you want to use PLC4X to access the PLC, you have to know its IP address.
Yeah, sure. You have to get some data. You have to know the addresses of things. Yeah.
But if you want to set the IP address on the PLC, you have to use the software.
Yeah.
And
yeah, because we couldn't just sort of every manufacturer, even if they use the same protocols, they have to be set up using their tools because we just wouldn't be able to sort of run that. What's this? That's a piece of hardware that was built intentionally for PLC4X. I'll be talking about that in my talk.
So 11:30?
Hmm?
11:30?
Hmm?
You want to host. So you choose another speaker on level 3. Then we
By
come
the way,
back.
you've got your badge wrong way around.
Oh, okay, I'll go to level 3 first.
Hmm? Some screensaver.
That's your screensaver?
Nah, not really. That would be a total waste of CPU time. But you can see the device clicking. So it's a real PLC that's controlling a virtual factory.
Okay. That's pretty cool.
Yeah, cool thing is you can mess around with the factory. So
This is quite a little demo you got set up here.
yeah, well, that's actually just the device we have for testing. So that company isn't nice. That company is nice.
Oh, they gave you the stuff?
Yeah, that I bought.
Oh.
Yeah, so it's really interesting to see how the different companies react on the concept of open source.
Yeah, we have some.
Yeah, well, I'd say I always call them the dinosaurs. They sort of tend to be, well, we're crossing out. Yeah, well, they tend to be sort of more threaten you with lawyers, and the other ones threaten you to give you software and hardware for free. So those are the two types of threats you get. Yeah, so we have the problem. We wanted to sort of provide access to all these devices to everyone who's in the project. But it's really difficult because ASF infra is sort of virtual.
Yeah.
And try screwing something to a virtual thing.
Yeah.
So we set up in our Codecentric office in Frankfurt, we have sort of a wall. We've got these industrial rails.
Okay.
You just click them on, and it's a VPN
Okay.
that sort of everyone in the project can sort of request access to.
Okay.
And then you can just dial in. Well, if somebody wants to connect to the S7 device now, it's going to be a problem.
Because it's gone.
It's not there.
Yeah.
Yeah.
Still, pretty cool.
Yeah. And it's sort of starting to take off.
Yeah.
At the moment, yeah. It's quite a challenge for the past 2 years, but I think when I come back, it looks as if I'm fully booked for the next few months.
Oh yeah.
Mm.
Cool.
Yeah.
Where's your office at?
In Frankfurt. Yeah, but the cool thing is the blue device there.
Yeah, we were talking about it earlier.
Yeah, that's actually sort of something that allows a USP for PLC4X that I think not a single competitor, open or closed source, can provide.
What is it?
It's a network diode.
Yeah, I remember that, but how, like, what is it that it's doing?
Yeah, well, you
Making it
have the problem that if you want to collect data on a PLC, they are very, very simple pieces of hardware. For example, if you that one is able to connect 3 TCP connections.
Okay.
If 3 connections are there and the 4th one comes, it just doesn't pick up.
Okay.
And you can really easily sort of overwhelm these devices. And if you ask them too much questions, they just shut down. So imagine one of these is working in a machine doing some heavy business.
Mhm.
It's asked tons of questions by a control system and maybe some logging system. And now we come and ask questions too. It can easily shut down. So for us, it was very important to find a way to get the data without sort of interfering with the systems, especially if it's sort of in a controlled environment, highly secure. It's almost impossible to guarantee side effect freeness.
Okay.
And what we're doing now is sort of we have the so-called passive mode drivers that sort of intercept requests and responses on the network, and sort of from asking the question and getting the answer to the question at a certain time, we know that this value on that device at this given time had this value.
I got it. I'm gonna take this. Sorry about that. One sec. Hey, what's up? Jesus Christ. Sorry. I thought it was gonna go speaker. Hold on. I'm gonna go to headphones. You can hear me now?
Yeah, I can hear you now. I think we're gonna get started at 5 after for real. I'm gonna go throw some laundry in.
Okay.
But I tried the link to make more support.
so it doesn't feel like getting one of those. Oh, they're been bought. Jeez, like,
There's the purple, what's the other thing?
I just said, look, it sort of look like pads. Oh. Hey. Cool. Ooh, yeah. Those are from the 50,000 stickers, Sharon.
Yeah. Actually, that's what I got with too.
I'm here.
Yeah.
Can you not see me? I'm still here.
So Julia wanted to bring me some coffee.
I'm sure he was going to show it.
Yeah, give me 1 hot minute to finish. I'm getting ready to tweet the next talk.
Yes.
Sorry about that.
Blinky. Blinky lights, you must like it.
What? It's the light. I'm on my phone. It's a freaking Howard Johnson. It's a piece of trash. I hate it. I'm kind of pissed. I'm glad the foundation's saving money, but everybody else is getting hosed, and this place is a trash hole. I might have to get away from my computer here in a second because it's also running the live streaming. All right. Bringing up my drive, the book outline, right?
Did you have the full screen book in there?
No.
All right, we're on KF book outline, right? Yeah, looks like you're in here too. All right, cool. I'm up. What happened to Elon? Oh, the new, yeah. Your the one you came back with. I like this too. This is also good. I'm a big fan. Okay. Sure, and I don't know that we have to have 4 case studies as well. I was thinking about that. That might just be overkill. Okay. Yep. Yep. And yep. One baby, one big.
Yeah.
That works. And it can even be the same, really, example, just with a baby data set and a large data set. Yep. Yeah, that I agree. And also a problem for much later on down the road. Well, that's, I guess, yeah, we gotta have 6 chapters up in December, right? Okay, well, soon hopefully I'll have something, a working version of Kubeflow I can play with, and we can go from there.
I really like to use the detail diagrams. Have you
Yep.
ever seen them?
Yeah.
Yeah.
Okay, let me know if I can help with that. I mean, like I said, if I still don't have the whatever, it's okay. Okay. Yeah, which it did. I mean, which was kind of how Kubeflow was when we wrote that thing. But it's whatever. Clean. I agree. I'll try to get Minikube. I'll try to just do the Minikube. Well, you said you're having problems with that too, right?
Flight and,
Okay. Well, I'll see if I can get Minikube with 061 and hopefully at least get that halfway working.
Stop working.
Well, that, yeah, I get that too. Yeah. All right. All right, so 6 chapters.
So you might not have this problem. It's just a good nuisance. For the better size.
It's everything is sort of fixed size.
Okay.
Yeah.
And as I sort of hacked it in there,
What I tried to do was this, which would, because it has a coming side.
How much do you want
Footer
written?
in there, display numbers.
How much do you want written?
okay. Maybe something other is overriding it. Just have a look at the.
I couldn't see anything. Is it-
But if you go to the.
Yeah,
the
yeah.
shouldn't it sort of show you the effective styles?
Hmm.
So it's not taking the style, it's saying.
The thing is, it's inside the iframe, which may be problematic.
Yeah.
But
Why is
the
the timer running anyway? Because it's coming from the website. Because the timer doesn't run if you
I can do
just
some work
open
on
an
this too.
HTML
Yeah, it
file.
does for me.
Why that? Because that's the only reason I need to sort of.
Okay.
Yeah, that's what I thought too, but I
Maybe
Maybe they
the
changed
containers.
something with an update. That might be.
That's cool. Yeah, when we get there, like I said, I've still got the blocker of not having a working thing, but as soon as I'm up, I should be able to. And you can just assign me tasks.
You can
Is
even add, I think,
we cut
timing
through that.
information that it tells you if you're on time and if you have to speed up.
I'll work on. It sounds like Boris is getting ready to work on it as well, so we can both do that. I mean, like, kind of the same way with the data prep and the notebook. We'll play with it the next couple weeks, and then we'll figure out what the hell it is, and then we can write.
He's a busy man, so
He's coming here.
anything.
So I sort of created
The pipeline.
I haven't tried anything out.
Well, no, that's what I'm saying. There's the pipelines as well, because it seems like that's where we're going to write. It's that lightweight pipeline container or pipelining that you can do from the notebook. Yeah.
What's the time with the
In the morning.
Yeah, we've got that for 5. Mm-hmm. Yep. Just make people aware. Like, here's a thing you can do too, and because that's going to be probably developing quick. Just like, here's the 101 and read more. Yeah, and awareness.
There's a reason for it.
Just have one time zone and just get used to the offset. There'll be interesting things happening with daylight saving where because they sort of population decide if they want to get rid of daylight saving.
Why?
Because it's annoying.
Yeah, it's annoying, but it's also good.
Just checking the recorder.
Okay.
Sorry. Just now, I'm trying to get the lights going or something.
Okay. Ducktail. I think the US works without ducktail.
So when we live stream this,
YouTube. We posted the link in the ApacheCon
all right.
workspace.
As I was on stage, you
Hmm? Yeah, but it did work as you could hear. Ah, yes, you could go to it and have them look around. Yeah, that might be the old one. Yeah, I think that's the old one. That doesn't work. Go back and we posted this. Yeah. Then I asked if it's sort of offline and the things. The link. Ready for the finger. So it's just one. So how,
Yeah, that makes sense.
Huh? You hear me?
Yes.
With a little delay. Huh?
Have you talked to him recently?
Yeah, I think the mini is bigger. And it's sort of as big as the entire chip.
The smallest ones are these ones.
Okay.
This one here.
Okay. Well, it's not bad. It's
Yeah.
so, because I need to sort of finish my robot. The thing is, 7 devices aren't fastened to sort of detect the delay between two events. They can just count pulses. So I need to sort of translate the difference between pulses into single pulses toward left and pulses toward right.
Yeah. Well, I mean, we were all running around doing everything too because we were waiting for 06, and maybe just needs to kind of be made aware, like, hey, we're doing things again. Check back in.
Those are lights.
Oh, really? Okay.
That's a lithium battery charger.
Yep.
I really love the. Do you know if any devices able to run minute that?
Well, we only have to have 6 chapters up, so make that one a late one.
Network.
But it would be possible.
Mhm.
Yeah, because that would be
Yep.
what I was
I'm
planning.
not seeing the update, though.
Because you can't connect the communication protocols to the PLC secure.
Oh,
So I'd love to sort of
okay, got it.
Cables with PLC for X on my node at the end, and that sort of just translates from
You got it?
7
Okay.
to something that's secure. Well, probably just Thrift, and from Thrift, then using proxies, proxy PLC for X. The other one was just for
Shearing.
Five.
That's the blinky lights version.
But it's there's the blinky light shoe.
Okay, that is never Arduino.
Yeah, that's the
Okay, and the other one is the power management thing in the middle.
Yeah.
Okay.
The other ones are just breadboard.
That works for me. And that's what, beginning of December, right? Cool.
Yeah, well, size comes with
Okay. Which, it's going to be Thanksgiving, so it means really middle of November. I mean, Thanksgiving's there. Yeah, so like realistically, then it's middle of November. Oh, okay. Trevor doesn't, so that's fair. All right. I'm gonna mark the artifact thing as solved. We're at.
Maybe, like, for some reason, something.
Awesome. They don't. I did some stuff for well, I will, but I wouldn't bank on them. Well, that's kind of, I mean, I was really just trying to make it survive one last bout, and it was right. Wait, what are you giving this 2 more times?
That's what was added on C.
Okay.
It did support floating before with float and whole, but it's
All right.
Yeah, okay, yeah, when I was working on CP5, IEEE 754 was just on the edge of having chips available.
Do you want
Do
you want edit rights or just the link? Whatever, I'll just add you. Let's see. Holding the Gmail, holding Carrot Gmail.
there's fewer and fewer voting points are not likely to be 75.
Got edit. All right, you got edit rights.
And in some special cases, some bills fall like very compacted. Yeah, that makes sense.
Yeah, that was C99.
Yeah, but I remember the rule about doing calculations in double, even if the inputs were float,
Yeah.
as being in K and R.
Yeah, a lot of this deck isn't going to make sense. I'm just looking through it now. That's well, okay. Wait, hold up. Where are you? What are you looking at? I want to be able to see this. Oh shit! I'm gonna have to get out of this room real quick. Hold up. I'm gonna go introduce this real quick, and then I'm going to bail out 1 second. Ready for an intro? Ready to start?
Have a few minutes.
Okay. Okay.
3 minutes.
All right. I got 3 minutes. Why are we putting Alana in charge of that? Got it. Okay. Mm-hmm. Yeah. Yeah, I know. That's why I thought it was hilarious putting a lot on it. Yeah. Okay. There you go.
I got the coffee first, and then you talk for half an hour. Yeah, cold coffee.
I'm sorry. Does it count?
Yeah, I guess I'm.
Good. All right, I'm gonna bail off. I'm gonna introduce this talk, and I think we're good. All right. No, I'm flying out tomorrow night. Yes. All right, cool. Maybe lunch or when do you get in tonight? Tomorrow. Okay. All right. That sounds good. I'll catch you tomorrow. Ready? Yeah.
You did it, Chris?
Yeah.
I'll just
Or you can if you want. I don't care.
No. Coffee's cold anyway.
So everyone, welcome back from the coffee break. The IoT track. This is Christopher Dutz and episode 4, A New Hope, Industry Done Our Way.
Yeah, had to trick that a little after updating my presentation framework. Everything was sort of small and didn't look nice. Welcome. As you can see when looking down here, I think it's called Industry of Things because you're always traveling with a lot of things. Imagine how security looked when I was checking in with all of this in my hand luggage. That was quite interesting. I think I put the animation speed a little slow, but I think it's the same text I had in the proposal anyway. So, welcome to IoT Wars, episode 4, Industry 4.0 done our way. So first of all, maybe a little on who I am, because sort of usually IT guys don't do hardware, and why I like to talk to these little gray boxes we have down here. So I'm a senior IT consultant. I work for Codecentric, and I'm a real open source enthusiast. So all of my free time, sort of, and well, all of my working time goes into open source projects. All of them sort of at Apache. Over time, let's say, when you start with Apache, you start with one project, but that usually doesn't stay that way. So I think I'm a committer now in about 10 projects. Become a member, I think, 5 or 6 years ago. And now I'm also VP of the Apache PLCFX project. And now, maybe to close the gap why I like these other devices, I'm the son of an electro engineer. So the second, let's say, computer I had on my kiddie desk was sort of an S5 from Siemens, but usually now the S7 devices are a little smaller. I remember the S5 being sort of like a little suitcase, but sort of got me hooked on that. It's sort of fun to write a little program and it sort of clicks and does things in the real world. I will probably mention the one or the other company a few times. This isn't planned on sort of being an industry bashing talk. It's just sort of the one or two companies I'll be mentioning I come across most because they're sort of mainly in Europe. I think all of the things sort of apply to all of the major manufacturers of industrial hardware. And I think they're doing a real good job. They build really, really great hardware. But let's say software-wise, well, yeah. So what's the current situation in the industry? Well, let's say the buzzword Industry 4.0, it's sort of everywhere. Everybody's talking about it. Most people don't even know what it is, but they just want to have it. Sort of like the cloud 10 years ago. Everybody wanted, I want to go into the cloud, if it makes sense or not. Everybody's talking about Industry 4.0. And if you start asking what that means, it's sort of, you quickly find out it's sort of IoT technology, it's sort of cloud technology, it's big data technology, and more they're starting to adopt machine learning tools, and well, let's call it AI technology because they like it if you call it AI. And it's currently already quite a thing, but if you look at some charts, it's sort of everyone is under the assumption that it's quite good now, but it's going to go through the roof during the next days. I intentionally didn't put any sort of source in there because I didn't want to trust just one source. So I did a little research and I found out there are a lot of studies. And they all have different metrics, so you can't sort of put them on top of each other. But if you just have a look, one thing you do notice is the shape is sort of always the same. It doesn't really matter what metric it is. So please excuse me for not putting any source underneath that. It was just sort of a curve. But the thing is, all of these technologies I was mentioning are completely new to the industry. They have never, ever before done any of that. There is absolutely no know-how there. If you go to normal industrial companies, they do have an IT department. Let me call this OT from now on. It's sort of operational technology. It's sort of they keep the machines running. They ensure the Windows machines are up to date and sort of take care of the networking, but they're absolutely unfamiliar with all of these big data cloud stuff. So what do these industrial customers do? Well, they do what they've always done. They turn to their manufacturer, and they really hope they will help them close the gap. But these topics are completely new to the vendors. They also usually don't have any know-how regarding cloud, big data, machine learning. Well, machine learning maybe a bit. They just don't have any know-how. So what did they do? Well, they start buying other companies that have this know-how. So in the last few years, you've probably seen in the news all the time, some major vendor buys some minor vendor for an insane amount of money. So that's what's been happening for the past few years. And well, they are starting to try to hire more and more skilled people. So if you're sort of starting to get a reputation in this area, you do get calls from the major vendors every now and then. So that's what they're trying to do. Yeah, but for now, I have to admit, they're sort of doing a really good job at destroying their reputation at the moment. Because a lot of the projects they've started have failed miserably. That will probably change in the future, but currently it's sort of not going very well. The problem is they've been doing it the same way they've been doing business for the last 20 years. It's usually closed source. Well, even if they are using a great percentage of open source in their products, what they're building is usually closed source with restrictive licenses. You can't just sort of say, yeah, well, I'll just try out this service. Well, you have to put it through the legal department because the conditions these vendors usually put into their contracts, they are insane. Stuff like no guaranteed uptime. If you send a bit of data into their cloud, it becomes their property and they can do whatever they want with that. So it's sort of strange. They are insanely expensive. The prices I know, for example, if you sort of decide to go down the Siemens path with MindSphere, they have changed the rates a little, but when I started looking into this, you had to pay 10,000 euros per developer per year to access the MindSphere cloud. Well, you could do it with a free registration, but you wouldn't see anything. So if you wanted to do anything, you had to pay 10,000 bucks per person per year. And then you had access to the platform. But if you wanted to do something on it, you had to add more coins. And that was an insane amount of money. They seem to have changed to some budget plan, but it sort of allows you to pump data into the cloud. But if you want to do something with the data, it gets more expensive than with the regular plan. So I don't think that's quite a good idea. And one thing that I really hate is the restricted connectivity. So if you go to the cloud solution of vendor A, then you will be able to perfectly integrate with all the products of vendor A, but you will be having insane problems integrating the products of vendor B. And only very few companies have products from only one vendor. So what I like to compare all of these solutions with is sort of like the Death Star. Yeah, it's insanely expensive. I'd call it pretty proprietary. Well, it's pretty inflexible because all you can really do is blow up planets, but you can't do anything else with it. But on the other side, it's so insecure that you can just blow it up with a two-man plane. I guess the US guys here, you had this petition of building a Death Star. I really love that. So I got a few of the numbers from that, and that was quite entertaining. And I thought, yeah, well, it's sort of the same way the industry is doing things at the moment. Sort of, they're building this huge thing. You can do very little with it, and it's insanely expensive and, well, unfortunately, not pretty reliable. But that's what we've been doing for almost a decade now. Modern IT, let's say everything Apache, for example, has in its repertoire, it's solutions for all of these topics. Modern IT has plenty of skilled people to sort of start solving the industrial problems because that's what we've been doing for the past 10 years. It's maybe a slightly different topic, but it's the same set of tools, it's the same procedures. So it's just doing different calculations with data from different sources, but well, that's not that difficult. And all the industry really has to do is start asking us. So between Christmas and New Year's Eve, there was a really good tweet from a company called Bain. Have to admit, being from Germany, I didn't know that company, but I think it's sort of a big thing in the US. They seem to have a lot of customers. And they asked all of their customers in the IoT sector, what threats do they see in adopting all these IoT technologies? And that's what came out. Well, probably you might have problems reading. Topmost is security. Second is IT-OT integration. Unclear return on invest, technical expertise, interoperability, data portability, vendor risk, transition risk. Yeah, vendor risk, I didn't quite know what it is, but it's sort of the risk of betting on a horse and that horse sort of dying on the way. What do you do then? Legal regulatory issues. That was what I mentioned with all of these sort of legal issues with their license agreements. Network constraints. Yeah, that's one thing I always sort of thought. The way you're going to do it, that's going to be your biggest problem, because let's say 2018, when I was traveling around talking about and preaching about open source in the industry, what they all wanted to do is we want to get all the data every 500 milliseconds and pump that into the cloud. When I usually ask, so what do you want to do with it? Yeah, well, we absolutely have no idea right now, but we have to get the data and maybe we'll have a good idea what to do with it sometime. But if you just sort of, it was usually just taking out a calculator and saying, okay, well, let's assume you're getting 1 byte of data per measure. You want to have 2,000 on each PLC. You've got 2,000 PLCs. Well, you need this type of internet connection to just physically shove it through to the cloud. And then usually they say, oh yeah, maybe that's not that good of an idea. The problem that was down there is sort of the vendor lock-in risk. And I also thought that would be considered quite high. So let's focus on, let's say, the barrier connectivity. As I mentioned, if you're sort of in this sector, the problem is machine A doesn't talk with machine B. For example, I've got 2 devices here, one from Siemens, one from Phoenix Contact. They all support a variety of protocols to communicate with each other, to communicate with the outside world, but I think not a single one to talk to each other. I think if you want to send data from that machine to that machine, you have to use the Modbus protocol, which is very, very, very old, very limited in its features, and well, it's not really integrating. It's sort of like, to translate it into modern IT solutions, it's sort of like integrating 2 systems by dumping CSV files and parsing them again. It's sort of very, very low level. So the problem is those devices can't talk to each other. That was because most vendors started with offline versions, and then all of a sudden they needed to connect them. So they started building their own protocols. There are some standards, as I mentioned, Modbus, that's sort of used all over the world, but let's say I think in the Asian world, Modbus has a much higher adoption. On the US continent, it's generally more Ethernet IP based. In Germany, it's sort of pretty dominated by Siemens. But the Siemens one is sort of a proprietary one that's just used by one vendor. Yeah, so the problem was there was no universal way to communicate with each other, and in the end, the customers agreed that this is a problem, and they sort of increased the pressure. So all the vendors joined together and sort of founded this OPC-UA, or the OPC Foundation, and this created a new protocol called OPC-UA, and that's aiming at becoming the next standard. So, well, currently that's the problem now. We have some industrial hardware that's got data, that's got something to say, but we just can't understand it. So, speaking about OPC-UA, it's a new standard for inter-machine communication. It's defined by the OPC Foundation. And if you go onto the screen, it's sort of every vendor you could think of sort of has its logo. So everybody is involved. a lot of people being involved. I don't know if you know how decisions are made by at Apache sometimes. A lot of people having something to say. Well, it does slow down processes a little. In this case, it's sort of, they've been working on OPC UA for about 10 years. It's still not finished. But let's say, I think in autumn last year, they added this publish subscribe feature. So let's say autumn last year, we have an OPC UA version that is actually usable. It goes a little beyond usual industrial protocols because it additionally not only defines how to transport data, but also the semantics of data. The industry is currently selling it as the solution to all problems. And I agree, OPC UA is generally a good thing. But on the one side, currently I don't know a single OPC UA enabled PLC that natively supports OPC UA. So how's the industry doing it at the moment? It's sort of like, this is a small version of the S7. If we went to the 400 models or the 1500 models, what Siemens did is they just took the original one and they plugged an application server on top. So as soon as you activate the OPC UA subsystem, it's like a little application server running on that device. And let's say the performance is less than ideal. In field tests, we were sort of engaged to solve a problem because using OPC UA, they were able to get out of one of the big PLCs, they were able to get 200 data points every 2 seconds. And if they went above that, the whole PLC just shut down. And thinking of 200 data points every 2 seconds, I think you shouldn't even start thinking of machine learning and stuff like that, because you just need a lot more data and a much higher granularity. So right now, OPC UA, it needs to be integrated to become a first-class citizen on the PLCs. Then it's going to be a good thing. And on the other side, yeah, it's sort of, it's being sold as the new standard. And I agree. If you build a machine now, it's easy to get OPC UA support. But the problem is, in contrast, for example, here on my Mac, I get a new device for a working computer every 3 years. So it's sort of the time span I have to live with. But if we're building machines that cost millions and millions of dollars, they are usually built to last for 15 to 25 years. So what happens if I just bought a machine in spring last year? Then it's impossible that this machine will support the newest OPC UA driver. Well, I could now tear it apart and sort of add new PLCs or update things, but that's not what usually happens. So in the end, I've got a zoo of really, really old legacy machines that don't talk OPC UA, and then I've got a few new ones. So what are we doing now? Still sort of stuck. Yeah, that's sort of how I currently compare the situation. It's sort of like you've got the PLC, and then you've got the OPC UA attached to that little PLC, and it's sort of like flying the Millennium Falcon with a Star Destroyer attached to it. It's sort of doesn't feel that. I think he wouldn't have done that famous race with that setup. Okay, already told you about that. So we need something that sort of translates, sort of like R2, 3CPO, the multi-protocol droid. So that's what we need for open source software. And that's where Apache PLC4X comes. That's the mission statement of PLC4X. So PLC4X is a set of libraries for communicating with industrial programmable logic controllers using a variety of protocols, but with a shared API. So the shared API is the important part. We don't want to deal with all the individual aspects of different protocols. For example, if I communicate with a device with Modbus, that's pretty straightforward. You just send a packet and you get a packet back. If you communicate using the S7, you have to sort of log in on multiple levels of the protocol, and then you can start communicating. But I, as a software developer, don't really care about that. I just want to connect to that thing. So that's what PLC4X is taking care about. And now, please pay attention to some awesome image editing skills of mine. Yeah, Toddy, he really liked that. So you can think of PLC4X as being this multi-protocol droid. All you need to do is sort of bind into your application the API module, and you can immediately start writing software for communicating with any PLC. We also have integration modules for multiple frameworks, because if it was cool in the sort of beginning 2000s to have sort of a module to communicate with something, today it's sort of more like Lego. Nobody really wants to use a low-level API to communicate with anything. They're expecting integration modules, so that's what we're giving them. I'll tell you about all the modules we have in a few minutes. Currently, we started working on Java drivers, but we intentionally didn't call it PLC4J, because the difficult part is understanding the protocols and not writing Java code. So we're currently working on C++, C#, and Python, because we had people that were willing to do that. But we're also thinking about sort of Scala wrapper to include it in some of the typical big data systems. C, JavaScript. A lot of people are asking about JavaScript. I have to admit, I'm a little bit worried about JavaScript, but that's more a security issue with PLCs. But it doesn't matter what language. I think we will probably, if there is a big interest in it, we'll probably start working on it. So in the end, you're able to sort of write software almost independent of the actual PLC. And the cool thing is you can even write a piece of software for a machine that does something. And if maybe in 2 or 3 years that's replaced by a new one, and that now uses, for example, OPC UA, well, you don't have to change your application. All you have to do is change the connection string and some resource strings, and your application just keeps on working. In general, a big inspiration was JDBC. So all this concept of having a connection string and queries in string form, so that's what we also did. But in contrast to JDBC, let's say PLCs are very limited in what they can actually do. And some of the features they can do, we don't even want to do. So what we currently are concentrating on is reading data, writing data, subscribing to data. So for example, please send me an information if some value toggles its value. In the future, we're going to be able to sort of call functions. So for example, if your PLC sort of supports go into maintenance mode, and then the machine sort of goes into some positions where you can easily clean it or something like that. So we'll be able to call functions and to also browse resources on the device. The problem we haven't done too much on the browse resources yet is that all the protocols we started implementing just doesn't support that. So now that we're sort of going to, so we're currently supporting OPC UA, we're going to start on the newer S7 protocols. They all support browsing. So that's what's going to be, if I'm going to talk about PLC4X next year, we'll have more green check marks on that. Yeah, this was where I had to update my presentation framework, because we sort of exceeded what I could sort of list up in one row. So that's the list of protocols we currently support. Siemens S7, there it's the older protocol called Step 7. I don't know if it's the official name, but it's usually what you refer to. And that's the most widely spread S7 dialect. There's a German company called Beckhoff. It's pretty well known in Germany. Don't know how it is outside of Germany. But that was the second protocol we supported. We added Modbus, both TCP and serial-based, Ethernet IP, and a few months ago OPC UA was added. We're currently working on 2 Alan Bradley flavors. That's sort of mostly based on Julian's company. We did a proof of concept where we were the first to be ever able to communicate with Amazon Delta V systems. I'm privately working on KNX Net IP because I want to talk to my house. And I also just started working on BuckNet. That's if you don't want to talk to houses, but to factories or office buildings. So that's where BuckNet comes in. And we're probably going to start working on the newer Siemens protocol as well as Profinet in the next few months. So we've got that base covered. And now we've got this sort of flamingo colored bar down here. That was the legal issues. And the cool thing is, being in an Apache project, the base of legal issues is just completely covered. So anyone who wants to communicate with an industrial programmable logic controller, just use PLC4X and you've got all legal bases covered.
What do you mean by all legal things covered? So can you store data? What do you mean by all legal things covered here?
Legal things.
Everything?
Yeah, well, there is nothing to consider. You are allowed to use it in every circumstance. There is no restrictions on use. You don't have to pay any fees to anyone. You can just use it. You can modify it if you need to. You can do whatever you want with it, except call it your company PLC4X.
Because you mentioned the first one where the barriers, the biggest one was security. About processing data, and with this, so this is gone, so you can...
No, legal issues, not security issues. But I'll come to the security part soon.
Right.
Okay, so just wait a minute. I mentioned we have integration modules to other projects. Well, being an Apache project and being sort of fond of Apache stuff, we have integration modules for Apache Calcite. That was added recently. Apache Camel, Apache Agent. There's going to be a cool talk later on today about Apache Agent. We just finished a new version of Apache Kafka Connect, and I'm going to be talking about how cool that is in a few minutes. 2 weeks ago, we added a Logstash plugin. There will probably be an official Elastic module being released in a few months. That's going to be using PLC4X. Apache NiFi, well, I put that little wrench on it because I haven't ever been able to get access to some NiFi guru to sort of help me finish up that integration module. What I'm really planning on, and that's one of the things I have on my list, is being able to write drivers for Apache Minute, because security is a problem, and I'd really love to have a protocol adapter on a computer of the size of a network plug that you can sort of just plug in a protocol adapter into your S7 device and sort of get rid of some of the security issues. Also, I really want to sort of build bridges to the other IoT foundations, especially in the Eclipse world. There would be Eclipse Cura. That's a Java-based program, so it shouldn't be a problem. EdgeX Foundry is one thing I really, really want to support, but for that also we have to provide C-level drivers, and well, that's coming soon. OpenHub, I don't know if, do you know OpenHub? It's sort of a home automation framework, and a lot of people are asking for some proprietary protocols that aren't yet supported. So I think the community will really like support. So here's a little picture of the overall architecture of an PLC4X application. Assuming you're writing an application, well, you can, at the front, just use the native API directly. And as you can see, there is no way to sort of directly use the drivers. There's the API as a separator in between. Or you can just write an application that uses one of the integration modules. I have to admit, in the beginning, whenever we added a new integration module, I kept on updating this slide. I stopped doing that because it sort of wouldn't have scaled anymore, but I think you get the point. The thing is, you can plug in additional integration modules, and you can even integrate user drivers. So assuming you've got a variety of PLCs running in your system, and then you've got this one device that's been doing a good job for the last 20 years that you sort of developed yourself, and it sort of just only speaks a protocol you invented yourself, and you want to integrate that into via NiFi into some cloud system. Well, all you need to do is write a little driver for PLC4X, and you're ready to go. And writing drivers is really, really easy. So, speaking about code, here I have a little example. As I mentioned, it's pretty similar to some of the normal APIs. So in the beginning, all you need to do is you get an instance of the driver manager, and you ask him for a connection. And with this connection string, you sort of define, yeah, well, I'm going to use the S7 driver, and please connect to that IP address, and there are some additional information. We will probably change the syntax of these connection strings in a few weeks or months, depending on our workload. But in general, all you have to do is sort of provide a string, and you get a driver connection back. Not all PLCs support all functions. For example, to call a function. Not every PLC supports that. Or maybe not every driver supports writing, because writing, everybody wants to read data from a PLC, but everybody's sort of starting to freak out if you talk about writing data. So we're planning on providing drivers that, for example, support only reading and not writing. So in that case, I said we can write software that is independent of the PLC. Well, in the parts where we can't sort of, well, writing to something that doesn't accept writing doesn't make sense. So we wrap those with optionals. So, so if you sort of get a read request builder, and for example, well, the PLC doesn't support that, it would probably say it's not present, and then it will just sort of, yeah, it doesn't support reading. Well, it's a little bit bad example, because I think every PLC will support reading, but not every connection will support writing. But I think you get the point. So I have to get my access to this read request builder. And what happens now is I add items. And what happens here is sort of I define an alias, and then I put in an address. And we decided to stick with the typical way addresses are defined in that particular type of PLC. So in this example, we're talking to an S7 device, and in the S7 world, I think every engineer will notice that %Q0 addresses the first 3 output bytes of an S7 device. So it's these LEDs down here. It's sort of the digital outputs. The reason for that is that we don't want to, as software developers, we don't really care about these addresses. So we just go to the engineer and say, what's the address for pressure at this valve? And he just says, yeah, well, it's sort of this address. So we just take this address, stick the data type behind it, and we're ready to go. So in the end, we just create a request, read request object. And what happens now, I think these are, you just build the read request, and all you have to do is sort of execute it. And we built PLC4X that it does everything asynchronous. You could sort of have it sort of synchronously. All you need to do is sort of just behind the execute, just .get, and you have the sort of synchronous version. In this case, I'm sort of just firing a request and telling the program, so when it's completed, please call back here. And what happens now is we're getting back a read response, and that read response has a set of field names. Because when sending a read request, for example, it will always sort of return all of the fields I asked for. But if you're using a subscription, it will probably just send back the values that have changed or that have been asked for to be reported. So we get all the field names that have been returned, and we check the response code for each of these fields, because I could sort of ask for 10 fields, and one of them is just a wrong address. So it would be bad to fail all. So in this case, we would just check if the read response was okay, and if it was okay to output it, and well, in this case, if there was an error, to just sort of get the textual representation of the error and just log that. So, any questions to the API? Cool. Okay. So, with all these integration modules, we sort of solved most of the problems we have here. So, migrating data from one system to the other, that's not a real big problem. It's been solved before. We've got, for integration, for data portability, we have solutions. We can use anything sort of the industry, the open source industry has to offer. But the most important aspect hasn't been addressed yet. And it's sort of the barrier the industry is most paranoid about. It's sort of, I don't want outside entities to be ever able to sort of get access to my production machines. Yeah, if I sort of break a computer system that's running, that is bad. But if I, for example, turn off the fail-safes of, well, assuming nuclear centrifuges, things can go really bad. So that paranoia is sort of justified. So industrial espionage, sabotage, sometimes it's just compliance rules or regulations. For example, if any company wants to produce anything that a human sort of consumes, so medicine, food, then they have to apply to the FDA rules, the US Food and Drug Administration rules, and they are very, very strict. So it's not that if you want to do data science in your factory, you can't just sort of plug in some cloud system and have the data scientists run analysis on this data. So what currently the solution is validated software. It's sort of software where the communication part has been sort of certified and validated line by line that it doesn't have any side effects. The thing is, this validation is insanely expensive. So in one case, it was, in order to get data out of one factory, one part of a factory, they had to pay 800,000 euros in license fee per year to get, I think it was 2,000 to 5,000 data points out. And that's just insane. The industry seems to be, oh, well, it's always been that expensive. But when I first heard that, I thought, holy shit. Yeah, the problem is if I ask a PLC a question, that has an impact on the machine. As I said, if I sort of just connect it to any OPC-enabled device and I just ask it, give me 2,000 data points every 500 milliseconds, well, it will just kill itself. So even reading can have a bad impact. If you think of, you've got a chain production and sort of one of these PLCs sort of dies, well, the whole production stops. So that's a problem. So that's sort of the way it's currently set up. Yeah, so we have PLCs. They usually communicate with some sort of control systems, usually with a fallback. And then they have this sort of data historian device. It's usually a big, fat computer, insanely expensive. And if you want to get data out of the secure network, you have to buy some legacy software system that communicates with that legacy system on the inside. And you're paying hundreds of thousands of license fee per year. And the problem is, if you want to start using data science to sort of improve production, to be, to earn more money, and all of this money sort of just gets gobbled up by the software you need to do that, it sort of just, doesn't work. So what we did instead was to think about what is the actual problem. how can we solve all of these problems? And I'm really, really proud. And this is one of the unique selling points of Apache PLC for X, because I haven't come across a single other product that's able to do that. We built some drivers that are able to passively monitor traffic. And what it actually does, it sort of just, if some control system asks a PLC, please give me value X, and the PLC responds with a value for that, we sort of just capture the request and the response, match that up, and instantly know what value X on device Y is at a given time. And the cool thing is it has absolutely no impact on the PLC device. And it's extremely cheap because it's sort of for free. Yeah, but some companies still, well, let's say, they still don't trust the manufacturer of their network switches, for example, because they usually have administration ports. Some use default passwords, or there are hacks available to those managed switches you need for something like that. So they still don't trust. They would never, ever connect a managed switch to the outside world. So how can we solve that problem? I did do a little research, and there are some military-grade network devices that allow sort of unidirectional communication, but they sort of started at 50,000 euros per device and went up to 150,000 because they're usually sort of military-grade stuff. But we don't really need that. And I had the luck to talk to the owner of a German company, sort of concentrating on building such hardware. And they built the network diode for us. It's sort of a device that just lets every traffic pass in one direction, but nothing back in the other direction. And the cool thing is, using that, we can guarantee that there is absolutely no side effect, that there is absolutely no way to sort of access your internal network. Because that device isn't like a normal firewall. It's totally transparent. It doesn't have a MAC address. You can't target packet at it. Each packet coming from the outside is just discarded, and every packet that's coming from up there is just forwarded. So it's really a really simple system, and sort of the price of that thing is sort of targeted at sort of 500 euros. So we're talking completely different worlds at that. So in the end, this is sort of the setup we were planning on and what we're currently testing. You don't have to use certified software, because sort of the certified network device guarantees that there is no possible way that you can have a negative impact on the network. So in the end, we got all this colored, except these two blue ones in the middle. It's sort of the unclear return on invest. It's sort of what I said, yeah, we want to do big data, but we have absolutely no idea what we want to do, actually. So they need people to help them get an idea what to do. And, well, technical expertise, well, they can always call us IT professionals, because, well, that's sort of part of my day job, to sort of educate the businesses in technologies they want. So I mentioned, got to speed up a little. How much time do I have? 5 minutes? Great. We had a proof of concept request for a large car manufacturer. As I mentioned, they were collecting data with OPC-UA. They wanted 2,600 data points every 2 seconds. Yeah, well, they got to 200 every 2 seconds. Well, sort of, I think it would, if it was a school grade you'd get for that, it would be sort of a fail. Well, they weren't able to get enough data fast enough, and they also wanted some cycle synchronous data. So if you read data from a PLC, it might be that the first parts you have read, and then comes a new cycle in the PLC, and the second part of the response sort of with different data. So they needed something to communicate cycle-less synchronous. They also needed the infrastructure to collect data on, I think it was sort of about 26,000 PLCs. Yeah, they went to their major to their major manufacturer, and that one just miserably failed with that. The thing was they had to sort of pay 800 euros per PLC to activate OPC UA, and I think they needed about 5,000 euros per server, and they needed about 1,600 servers to process all of the data acquisition. So you can do the math. That was a number with a lot of zeros at the end. And what we did, a few weeks before they contacted us, we finished the first version of a Kafka Connect adapter. So the cool thing with this is it sort of just handles connections to PLCs, and Kafka Connect sort of automatically balances the number of PLCs. So each Kafka Connect node connects to 1/nth of the PLCs and just starts to collect data. If one node just goes up in flames, well, another one just takes over. We used ACA endpoints for cycle synchronous data. And well, we were able to collect 2,600. Well, we didn't quite get the 2 seconds because we just took 200 milliseconds. While we were able with the OPC UA approach, they were able to, on one standard virtual machine they have in their house, they were able to collect 20 PLCs, and then the virtual machine was overloaded. Well, we were able to sort of, I think we were able to collect on 600. 20 versus 600, that's quite good. So that's sort of how you can see how performant that is. Gee, now I really got to speed up. So what happened recently? We graduated to become a new top-level project of the ASF. We currently finished driver specification in a machine-readable format, and we're now able to sort of write a driver and generate the code in a particular language automatically. So driver development speed went down from sort of taking 3 weeks or so to implement a new driver to about 1.5 days. I think the last driver we implemented, we managed to do that in 1.5 days. We'll also be able to sort of port all the things we did to new languages by just providing a new language template. So I'm currently working on the C++ template, and I have to admit that isn't that much fun. That was why I was hoping Justin was going to say, oh, there are other options, but well, for my new, I will probably have to implement some C templates. That's going to be not that nice. In order to support a new protocol for all supported languages, all you have to do is provide a new protocol module. What we can also do now is what I mentioned, restricted versions. So I can now sort of provide a protocol, and I just say, yeah, I want a read-only version. So it just strips out all the code for writing write requests. Or I can create passive mode versions that don't have anything to serialize data, it's just for parsing. So you can be 100% on the safe side with this driver. You just can't write. You can't sort of through some loophole execute some code that's in the jar. So planning on integrating Apache Minute and Ajax Foundry. Julian's going to be working hard on some query optimizer for all protocols. And we're going to do some testing. So coming back to the chart from the start, those were the download statistics in Maven Central for Apache PLC4X. I see quite a correlation to the original charts of the growth of IoT. So looking forward to getting that line way up there. So what we need now is we need you. We need you guys to sort of help writing new protocols. If you know some language you want drivers for, come to us. Tell us about that crazy language you want, or even the old language. So if any one of you is good in C, you're highly welcome. So if you want to help, those are the options to sort of get in contact with us. Preferably our mailing list, but Toddy is quite good at Twitter in the meanwhile. So he's usually twittering what's going on with the project. if you find bugs, report them in our Jira. Submit pull requests. We're on GitHub. Join the discussions in the mailing list. Or just even if you hear somebody talking about, gee, I want to access some industrial data, tell them about it. A lot of people in the industry just don't know about PLC4X. And just tell them about them, what a cool project it is, and yeah, help us color the last 2 bars on the chart. So that's all, folks. After the lunch break, I'll be having a talk with Roman over here, showing you how to bring all of this glory into the cloud in mass scale with a cool demo. So I'd be happy to see some of you after lunch. So thank you. Any questions? Yeah.
Hey, can you back up to your slide where you show the network diode? What was the network diagram where you simplified everything?
That one?
That one. So I'm curious about why you think this checks the security checkbox. And it's probably because of my ignorance of what the security concern is, because all of the data can flow outside the network, and your PLC4X edge device is not validated software. How is that not a security vulnerability?
Yeah, well, it's sort of, let's say in the industry, the concerns of security are slightly different than the ones we have.
Okay.
For us, sort of getting data out is sort of the worst case.
Okay.
For the industry, it's sort of the other way around. It's other people coming in, interfering, reading out things they shouldn't read, manipulating something. That's what they're worried about. They don't really get. Currently, the solutions I have seen involve bikes and USB hard drives to avoid the paying of 800,000 euros. So what they did, they sort of just plugged in a USB hard drive, copied data to that, put it on, used the bike to right through the factory and gave it to the data scientists. So that sort of, the industry sort of doesn't have a worry of data getting out, it's sort of people getting in. And that's the concern they have. And I think the FDA rules, for example, they don't really care about what happens with data, but it just prevents people from manipulating.
Okay, I'm sort of thinking of the example you gave of the nuclear centrifuge, right? If you're just watching, let's say, RPM data, and all you want to do is just graph it over time, that data leaking out is not a big deal until you start looking at patterns.
Yeah.
And you can say, well, they take these things offline at the end of every month, and that's like information that an adversary could use against you. But it sounds like what you're saying is their first concern is they don't want anybody meddling from the outside.
Yeah. Well, let's say if I decided to stick with Siemens stuff for now, so I want to work with MindSphere, and I've got an S7 device, then I'd probably buy the Mind Connect brick, sort of a gray box, and you plug into the PLC, and the other one you plug into your internet connection, and it sort of pumps the data over there. It's sort of, my main concern is connecting PLCs directly to the cloud. And that's what a lot of people are doing. I think, what's this Internet of Things search?
Perhaps you should discuss this.
Oh, yeah, sorry.
Because everybody is aiming at lunch.
Yeah. Any other questions?
Just if you want to ask if this after lunch will be discussed, like when you put the data on the cloud, what about content management, GDPR, this will be discussed or it's out of scope?
Roman? Did you listen?
Yes.
I think GDPR we don't discuss.
But content management, like
GDPR is like Fight Club.
Content management, I mean, the approval of the user to know what data is being processed for what purpose. No?
No. Yeah?
As a passive driver, how do you generate requests that cause the data to reach the diode?
If it's not being asked in the network, there is no way we can do that. So usually it would be a sort of, if we would need a new piece of data out here, the control system would be configured to pull it. But that's not a problem for them. That's what they do all the time. Yeah. So I'll be hanging around here. I'm the guy running around with the cat. So just ask me. I'll be happy to talk about it. Yeah. So thank you very much. Yeah. Lunch break. Slot hat gemacht.
Okay.
I'm Steve.
Hi.
From Bethel.
Hi.
Hi. Certainly. Good to meet you.
That's right.
Yeah.
Yes. Okay.